Hey everyone, my name is Dan Lorenc, and I'm going to be talking about risk and reward, the state of open source software supply chain security. That's a bit of a mouthful. I'm currently the founder and CEO of a startup called ChainGuard, where we're focused on supply chain security and solving a lot of these problems. So this is a topic very near and dear to my heart. My email and Twitter are down at the bottom, where I tweet about a lot of these topics pretty frequently. So here's the agenda we're going to cover today. A couple quick topics. We're going to start out by talking about the state of open source security in general. Open source software is part of everyone's supply chain, whether they know it or not. So understanding the security of open source software is pretty critical to understanding the broader supply chain security problems that we're facing. Not every problem in the supply chain security space is relevant to open source software. And in a lot of ways, open source software kind of gets unfairly maligned for a lot of things. Every time there's an open source software attack, people tend to panic and talk about the problems with open source software. Not all problems here are specific to open source software. So I'm going to kind of break these apart and show that a lot of these problems would happen with closed source software as well. But some of these things are specific to the way open source software is developed in the open. And key to understanding how to fix those is understanding the problems themselves. So I'll break that down a little bit and show how open source is good and bad when it comes to improving supply chain security. And then not all hope is lost. I'm going to hopefully give some good news here at the end. We're going to start out by talking about the problems and scariness, but I'm going to point to some efforts going on today to help improve this for everyone. And then some links at the very end on how you can get involved with some of these initiatives if you're interested yourself. So this is the first scary slide, the chart going up and to the right. If you've been paying attention to security in the software space or open source software at all in the last year, this probably isn't news to you. This report came out from Sonatype in their 2021 State of the Supply Chain report. But we're seeing a whole bunch of new, Sonatype refers to them as next generation software supply chain attacks over the last 5 or 6 years. They're happening across all different language ecosystems. They're happening across all different types of software, and they're happening pretty frequently today. This includes things like typo squatting, which is where somebody might register a domain name or upload a package with a typo in it or a slightly misconfigured hyphen, something like that, to try to trick people into installing a malicious version of a package. Malicious code injection is another type of attack here that they treat as next generation software supply chain attacks. This can happen a bunch of different ways, usually like an install script or something like that when you first install a package, downloading and injecting some malicious code that makes it harder to find. Tool tampering is the final one represented here, and this is especially hard to find. This happens when your tools, you get compromised version of your tools that inject bad behavior to the code they're compiling or inside of a build system or something like that. These are especially hard to find. And as you can see kind of in this chart, 5 or 6 years ago, this wasn't happening at all, really. But the reports have shown that it's dramatically on the rise, especially in the last year. Almost every month, we've seen a new attack affect a widespread open source package. So things are starting to get pretty scary here. And thankfully, people are noticing from that same, actually, this is a different report. This is the Anchor 2021 report on this, where companies, CISOs, and leaders in security of organizations were surveyed. Last year alone in 2021, 64% of organizations reported that they were affected by a software supply chain attack. 36% said no. I'm guessing that they asked the wrong person or the person misunderstood the question or something like that. These have affected almost everyone. And even if you weren't affected directly by one of these security problems, you probably spent weeks checking to make sure that you weren't, because open source software is so pervasive. Finally, this might be good or bad depending on your perspective, but because of all of these attacks hitting critical infrastructure, regulations are coming. In the wake of the famous breach of SolarWinds that happened toward the very end of 2020, there's actually an executive order in the United States from the Biden administration this May, directing a bunch of different government agencies and the private sector to work together to improve the nation's cybersecurity. This was a long executive order that directed agencies to start to come up with real recommendations. So of course, it didn't specify exactly what we have to do directly in here to improve improve security. But it did set some very tight timelines that these various organizations are working toward. A lot of these regulations include things like SBOMs or software bill of materials. You might have heard that word come out of this executive order, which can be thought of as like a nutrition label on food. Right? Software bill of materials would be required from vendors to explain what dependencies, what third-party packages come with a piece of software, so that organizations using that can take that knowledge into account during purchasing and during patching and maintenance programs. There are a bunch of other things in here regarding setting aside some funding for open source. A bunch of different large companies have promised money to help improve the situation as well. There's also been work from NIST, the National Institute for Standards and Technology, to set up different reference architectures and recommendations for how software should be built and delivered to do so in a secure framework. So a lot of these things are still rolling out today. The executive order isn't done yet, and the recommendations are finally just starting to hit. So these regulations are coming, whether you know about them or not. They're probably going to affect you in your business if you're in the practice of selling software in the coming years. So why is open source under attack here, and why are we calling out open source in particular? Like I said before, supply chain security is about open source security. You can't really separate the two. Open source is in everyone's supply chain. This is from another survey, the Sonatype survey. 98% of code bases contain open source code in their audits. Again, I think that's probably an underestimate. It's a huge number, but I think it's probably an underestimate. I think the other 2% here were like that, the fifth dentist that didn't recommend the toothpaste. They must have misunderstood or didn't understand what open source software was. It's everywhere. It's pretty much impossible to build code today from scratch without using open source in some manner. Of that, though, on the flip side, 92% of these code bases contained outdated or vulnerable code. All code is vulnerable eventually. The code that we don't see vulnerabilities in today is just the code that they haven't been found in yet. The longer you look at something, the more likely it is to find a vulnerability. So just because something is secure when you started using it doesn't mean it is still secure. And this is a common problem plaguing organizations that are using open source software today. It's all over their code bases. They didn't keep track when they started using it, and they forgot to update it, which leaves them vulnerable now. Some famous attacks have happened this way. The Equifax breach from several years ago, based on an outdated version of Apache struts. This happens constantly where people forget to update software to pick up patches for vulnerabilities. So it's everywhere, it's getting old, and it's getting outdated and vulnerable. And organizations are now facing the burden of having to start maintaining and updating these packages. And the second reason that this is open source security is critical here is because supply chains are really about the links between organizations. And this is what attackers are having so much fun with today. If you're trying to attack a single organization, you have to get through their perimeter defenses. But if you attack a supply chain, it's usually much easier because you're attacking the gap between those companies, between those organizations. You're going after the points that are less secured in the middle. You're going after package managers rather than secure cloud environments. You're going after distribution networks. You're going after the way people install, update, and look for new versions of things. And we need to make sure that these links are strong. Nobody can solve this on their own because it's about how we communicate together. And this is why open source and standards play such a critical role here. So now we can kind of zoom in and look at the specific challenges for open source security. Now that hopefully I've convinced you that open source security does affect your supply chain. And it's pretty easy, right? It's right here in the name. There are a few things unique about open source software. The first one is that it's open, right? This means anybody can see the code, anybody can contribute to the code. This is great in a lot of ways. Linus Torvalds is famous for saying, many eyeballs make all bugs shallow. And that's one of the big benefits to improving security in open source software. The more people that can look at things, the more likely it is that bugs are going to get found. But this doesn't always work out, and it actually has some downsides that I'll explain. The second one here is that it's free, right? Most open source software, and the reason it's so commonly used and developed so widely and has made its way into organizations all over the world is because it's free in most cases. Open source software comes with a specific set of licenses that guarantee your ability to use it in specific ways. And that's awesome. It's much easier than having to go through a procurement process to get a piece of software licensed to use internally. But again, sometimes free isn't worth it. It isn't worth the cost. We'll go through a couple examples here too. And then finally, it's transparent, right? If there are issues, you should be able to look at them. You should be able to find them because you can audit all of the code. Unfortunately, the quantity of open source software out there today makes that pretty much impossible. Going back to Linus's law again, about many eyeballs. If you're using millions and tens of millions of lines of code, you don't really have time to look at each one of them and look for vulnerabilities. And we know how easy it is for vulnerabilities to sneak by, even if you are looking for them. So a lot of this transparency can just be an illusion depending on how you look at it. Let's go through some examples of each of these. So I like to use a lot of memes in my presentations. So this is the first one. Because open source software is open and anybody can contribute to it, that's great, right? Until you realize that not everybody on the internet is nice. Anybody that's spent time on forums or social media probably recognizes this. A lot of people do not have everyone's best intentions out there. And when you're taking code and running it in production environments with access to sensitive data, that can actually be pretty terrifying. People go through background checks and audits to work at companies where they get access to these environments. But anybody with a GitHub account can go and contribute code to critical libraries, which then make their way in there. Right? This is awesome in a lot of ways, like I said, but it can also be pretty terrifying, and it is really inviting for attackers. Malicious code commits happen pretty frequently. Libraries get taken over, packages get transferred to different owners that don't have everyone's best intentions in mind. There was a pretty famous incident middle of 2021, where some researchers from the University of Minnesota were trying to show how easy it is to sneak malicious code into the Linux kernel. They did this, the project was called Hypocrite Commits, where they sent some patches with known vulnerabilities in them to see if they would get through. Fortunately, the Linux kernel review process is pretty strong, and they actually caught a lot of these before making their way in. But nonetheless, I think a few commits did make it in, and they were eventually reverted. And because the style of the experiment was set up where people weren't warned ahead of time, the University of Minnesota got kind of sanctioned and in some trouble for doing this. This happens all the time, though, in other ecosystems, packages, and communities where attackers are doing it not with everyone's best intentions in mind and not for research. So it's something to keep your eye on. This happens in a bunch of other cases too, beyond just the hypocrite commits. There was a famous example of a Chrome plugin called the Great Suspender, which was an awesome plugin that would suspend tabs running in the background. If you're one of those people that collects hundreds and hundreds of tabs, this plugin could save your battery life. The person maintaining it handed it off to somebody else who immediately took the code down from GitHub and started inserting malware into the plugin. So the code changed from a kind of benevolent contributor to a malicious one overnight, and got malware pushed to people's browsers all around the world. Thankfully, the Chrome store took it down pretty quickly, but there are examples like this happening constantly. All right, moving on to the next bullet about transparency, starting again with another meme, right? Open source software is transparent. It is usually distributed in source form, and you can find the GitHub repository for all of the code that you're using, look through the code, and audit it again if you want to. But like I said, the vast volume of it makes this impractical in reality. Additionally, a lot of the code is distributed not in source form the way it's actually consumed. So even if you look at the source code for a Python or Node.js package, when you run pip install or npm install, you're actually grabbing a package form which has been compiled. And in a lot of these cases, there's no guarantee that the package actually came from the source code you audited. So depending on how you consume source code, if you're not actually grabbing the source code yourself and compiling it from scratch every single time, then a lot of the transparency can be an illusion. You might be using binaries that have been tampered with or came from source code that wasn't in the repository at all. And we've seen a few cases of this one as well. with tampered builds, whether it was done on purpose or whether the build process was attacked. A couple famous examples of this earlier this year were the CodeCov breach. CodeCov is a free service for sharing code coverage, which kind of shows you the percentage of code that is covered by unit tests. This is super useful when maintaining open source projects. Their installer for CodeCov, though, was a bash script that was installed with curl pipe to bash inside of a CI system. This script itself got compromised and had some malware put in it that would steal secrets. So the build process here was actually tampered with and was exporting people's secrets to an attacker. A lot of those secrets, the secret tokens, access tokens, that kind of thing, could be used to publish packages to things like NPM or Maven Central and stuff like that. So the CodeCov breach itself was actually used as a pivot point to form another set of supply chain attacks where other builds could get tampered with. That's one of the other kind of tricky parts about supply chain attacks. Another famous one from last year, maybe it was late 2020, I can't remember the exact date, was the PHP server that was managing the source code repository for the upstream PHP project. Sorry. This was actually compromised and a couple commits were injected directly into the source code repository. Thankfully, it was detected pretty quickly. The commits were backed out, and then the server configuration was locked down and migrated to another host that could be more easily secured. This was a case where the source code itself was tampered with directly without bypassing the code review and bypassing the project review process. Similar thing happened to the server hosting kernel.org years and years and years ago for the Linux kernel. This was audited and no misbehavior is actually found, but an attacker could have done something in that time. This happens to projects quite frequently. It makes it hard to secure and make sure that the packages being built are actually distributed securely. Now, finally, this is what we started to see in the news in the last couple of weeks a lot during the Log4j vulnerabilities reported right at the end of 2021. Open source software is free. This makes it super easy to use and gives you a great distribution network as a maintainer. Unfortunately, sometimes free isn't worth it. Right? If organizations start depending on something and it becomes critical infrastructure, they might require security patches to be done quickly. They might require a whole bunch of extra work be done to get these packages up to compliance. Unfortunately, free comes with nothing, exactly like it sounds. In a lot of cases, this puts burden on maintainers that are doing things in their spare time, and the code might have been up to quality at one point, but hasn't been maintained in years. This sort of thing happens all the time, and sometimes free just isn't worth it here. If you need to get a patch in, if you need to get a vulnerability fixed, and there's nobody there anymore because everybody has jobs or needs to work to get paid, then you might not have permission to get these fixes merged. Something might get abandoned. This type of thing happens pretty frequently too, and is a hot topic every time there's a bug found in a critical piece of open source software. The Heartbleed attack from years ago was one of the first wake-up calls showing how much of the internet's critical infrastructure runs on volunteer work. And this happens every couple of years as a reminder and a wake-up call. The Log4j stuff a couple weeks ago, Log4Shell was the most recent one, but this happens a lot. There's a very popular Golang library for JWT parsing and authentication called JWT-Go. This made its way into dependency trees across the entire Golang ecosystem, even in projects like Kubernetes. This was great until a vulnerability was found inside of it, and then it turned out that the maintainer was no longer around to merge fixes for it. This led to a bunch of chaos in the ecosystem where people were forking it different ways, applying different patches to fix the same bug. And it just led to sprawl in the dependency tree, where before there was one version of this library with a very small bus factor because it was just one maintainer. Shortly after that, there were 5 or 6 different competing versions with different patches for the same bug, making their way around the dependency tree. And it took a while before a single one emerged and fixed the vulnerability for everyone. Heartbleed was the most famous one, again, like I just mentioned, but this type of thing happens across all languages all of the time. It's a pretty common refrain when it happens for people to cry out asking for companies to start funding the work. And there are programs like GitHub sponsors and different foundations providing benefits for maintainers to get paid for their work. But it's not easy, right? You can't just hand people money and get more secure code. A lot of people have full-time jobs and only have time to work on nights and weekends, and handing them a small check doesn't really work. This is a really challenging problem to get professional time, professional maintenance on the vast long tail of open source software out there. It's not as simple as just throwing money at the problem, as everyone should know. All right, time for the good news after all of the scary stuff that we just went through. Not all hope is lost, right? It's just software. We wrote it and got ourselves into this mess, so we should be able to get ourselves out of it now that attackers have found it. I think there are a couple exciting initiatives going on to help improve kind of all of these aspects: transparency, security, funding, everything. So let's go through a couple of these. The community, I think, is our biggest strength. First of all, the community is the open source community. These maintainers out there putting in their time and effort and sharing their work has made open source so pervasive across the industry and inside of everyone's supply chains. That means we can leverage that same community. We can leverage the same open source to start securing it. Right? This is a tweet from a couple months ago that got a bunch of jokes and funny responses back to it. But I think the core value is true here, right? Instead of each company needing to go build their own secure versions of all of these libraries, we can start to secure them once, find the critical ones that are being used by everyone, and improve, kind of lift the tide up for everyone at once. So leveraging the community here, we've got a couple different ongoing initiatives. The first one I mentioned, software bill of materials. This came up before when talking about regulations. But these really provide a couple different benefits when thinking about securing the open source ecosystem. One of the giant challenges is the lack of awareness or knowledge about which open source software is used where. Companies might not actually know if they're using something like Log4j or OpenSSL. They just know that they're consuming an application and they don't know what's inside of there. Providing this transparency is only going to help. People are going to realize which projects are critical and are running in these privileged environments and are making their way across the entire industry. And that can help feed extra funding efforts, like I'll talk about a little later, and audits and more proactive work to help make sure that these projects are maintained. To secure package managers and help audit supply chains to make sure they're not tampered with. There are a couple initiatives here as well. One of them that I'm going to cover a bit more is called Sigstor. This project has been around for about a year now under the Linux Foundation, and it's hoping to provide for open source maintainers what Let's Encrypt provided for web browsers over the last 5 years. Let's Encrypt made certificates free and automated to get, which helped lead to people adopting TLS across the web. Sigstor is aiming to do the same thing for code signing, so we can actually assert the provenance of source code and understand where it came from and make sure it hasn't been tampered with as it makes its way through package managers. And then finally, the funding problem. I said throwing money at the problem won't make it go away, but money is still necessary to fix a lot of these issues. So there are a couple different efforts to start making it easier to fund maintainers and get them the resources they need. And one of the most promising ones is the OpenSSF, the Open Source Security Foundation. So I'll talk about some of those sustainability efforts as well. Starting here, this is a high-level picture of what an SBOM might look like and is designed to contain. When you consume this application here all the way to the right, Acme application v1.1, right, as an end user, you don't know what's inside of there. You don't know that you're depending on Bingo, Buffer, or Carol's compression engine, which means even if you did want to help, if you did want to send patches, if you did want to audit or fund the maintainers, you wouldn't even know how to because you don't know that these are in use in the application that you're depending on. So by asking people to generate software bill of materials, by asking open source projects to provide one as well, by building better tooling to do this automatically throughout the build process, we're really going to get the transparency we need to understand which packages are critical so we can focus our resources on improving them. There's some great tools emerging today. There are a couple different SBOM formats and some awesome tools to make it easier to work with so you don't have to generate giant XML documents by hand, which is everybody's least favorite thing to do. And we're starting to see adoption of it as well. one of the Kubernetes releases of 2021 actually started to package a bill of materials with each release cut. So this is a huge JSON/XML document today, but it's already seeing use. The sprawl of dependencies inside of Kubernetes, one of the most adopted open source projects out there, has led to maintainers actually trying to curate those dependencies and reduce them over time. Instead of just growing and getting more and more tangled each week as people add new functionality, this has led to a conscious effort to reduce the dependency count and make sure that Kubernetes only depends on things that are responsibly maintained and have large bus factors. So it's not just one person and all of these things. So again, by showing the transparency of one project, we're seeing an improvement of the dependency tree for everybody using Kubernetes. Sigstor, these are some complicated architecture diagrams, and we could do a whole talk on this at some point. But the real goal here is supply chain transparency. I talked about before, if you npm install a package, you're actually getting a built artifact. You're not getting the source code anymore. And there's no real way to make that link secure. We don't know which source code went into that artifact. There's no way to cryptographically prove that. Fortunately, we've had this technology around for a while. We have digital signatures. We have code signing certificates. They are just not accessible for open source maintainers today. To get a code signing certificate, you have to pay a bunch of money and have somebody come and audit your business and prove that you are who you say you are. This might work great for large vendors shipping pieces of software, but it doesn't work for individual maintainers. So just like Let's Encrypt did for browsers, setting up some standards where people could request certificates and get them on the fly through a lightweight verification process, Sigstor aims to do that for open source maintainers. People can run a single command, have their browser pop open, verify their identity, which is based on an email address or OpenID Connect protocol, and get a code signing certificate that they can use to sign open source packages as they're built. And this can be integrated directly into build and CI/CD systems, so you can sign things without having to manage keys or YubiKeys or have key signing parties or anything like the old days. And so making a huge set of developer-first tooling that's automatic and free is going to help improve the integrity of open source supply chains all across the industry. Then finally, the sustainability piece. Money is not the answer, but it is necessary, right? It's not sufficient, but it is necessary to fix a lot of this. It's kind of crazy that huge projects are built by volunteers and then used inside of code bases making millions and billions of dollars a year. It's not always fair, but it's not always easy to fix either. And so organizations like the OpenSSF, the Open Source Software Foundation, are pooling money together from companies across the industry that are interested in fixing this and setting up programs to hand out grants and hire full-time maintainers that are dedicated to improving the security of code bases. They're setting up free audits that open source software projects can request to get security experts to come in and look and provide reviews and look for vulnerabilities before they're found by attackers. So we can start fixing things and getting ahead of the curve here. So there's a bunch of different programs inside of the OpenSSF. You can find them at openssf.org if you want to get involved. So hopefully that presentation kind of pointed out the state of open source security across the industry, showed some scary stuff at the beginning to get your attention, and then left on somewhat of a high note. If you want to get involved in any of these initiatives, here are some links. And if you want to reach me, here's my contact information one more time. So thanks for listening to the presentation today.